Hey guys, how's everything going? This is JSer who is not good at algorithms. In this video, I'm going to take a look at 188, best time to buy and sell stock for. We've already accomplished the previous three related problems, which is 1 to 3. Please search on my channel for details if you want. In this problem, the requirement is basically the same, except that we are asked to complete at most k transaction. The previous one is 2 or 1 and infinity, right? Now we are said to ask to do it most k times. How we do it? Well, for this kind of problem, I think dynamic programming would be the best approach. Let's analyze the example like this. So suppose for k, okay, so for k transactions, let's just go to the last element directly. So suppose, as we always do for dynamic programming, if there is an optimal case, suppose there are some trade picks of the index. Now, if 3 is not in it, then it actually just could be removed, right? The problem is same as we handle only the previous integers. Okay, if 3 is in the optimal picks, it's a pairs of index, right? Buy, sell, buy, sell. So if it is in it, then it is buy, it is sell. So there must be a pairing index. So which one is it? It might be 3, might be 2, might be 6, might be 5, might be 0, right? Suppose it's this, then it means, okay, in the k, at most k transactions, k minus 1 transactions at most were happened in the sequence before it, right? So it's typically like dynamic programming. Let's suppose that k I means at most k transaction and n at index I, right? So it equals to if okay, it equals to should be equal to, let's write it down. Okay, max, right? As we said, it might be unused. So we say k I minus 1, right? It is not used, or it is used. So it is used. How we do it? It is used. There are I minus 1 possibility as the pairing index. So it's still another max. So for suppose the index is j, with j from j 0 to I minus 1, right? As the beginning. So what it will be? Of course, it would be a k minus 1, j minus 1, right? There's a edge case as when j equals 0. We're handled in our code. So basically, it's valid. Suppose k equals 2. It means we handle k minus 1 batch the transaction until 3, and then what we do, we plus ai minus aj, right? So this is our formula. We say if we want to get k minus I, we now reduce it to reduced to ak I minus 1 or ak minus 1 j minus 1 for 0 to I minus 1. So either way, we will drag the index k or I down. Right? Yeah. So So let's try to do it. Of course, so the result would be actually a matrix. We could use that. We just use dp, okay? New array. Okay. Array k, field 0, map to array k, wrap to new array prices, and field 0. This is our result of dp. Okay, now we will loop through let t equals 1, t is smaller than equal to k, t go up, and now we will we will update dpt, right? So for let, as we said, n at index, I equals n at index, we start 1, I smaller than prices dot name I plus plus, and what and then we will, this could be get directly, and this will be a for loop to get, right? So we use for loop j equals 0, j smaller than I, j go up, this maximum, so let, okay, here max if used go to minus 0. We say so max if used equals max if used with the a, which is dp, k minus 1, which is t minus 1, t minus 1. Wait a minute, we initialize the array from t. Okay, now we get the previous one. That when we get k, there's no k actually. There's no dp0. There is. But finally, when we set dpt, that's gonna be a problem. To avoid things, we better initialize it with +1. Right? This is okay. So now we get t. Okay, this is gonna be all right. And then dp max, if dp is like this, j minus 1, j minus 1 plus prices I subtract prices j. And now we set to dp t I actually max and the previous one, so which is dp t I minus 1. Okay, so for t equals 1, because t starts from 1, it's no problem. And so finally, we could return dp k. Yeah. K prices dot name minus 1, right? Let's try. Mal arrow function. What is it? Map. Oh, run answer. So let's see what happened. T goes up for I. Max if used. What the? What the? Not a number? This is weird. Let's try to log the DP. I'll be honest, this problem actually cost me a lot of time. See the submission? So I'll try to reproduce the process I did at the beginning and to give you a better understanding, I think. Okay, I cancel log the DP. So basic idea should be okay, but now we get a null. The first, actually the first, okay, this, here it becomes a problem. It should be a 2, right? What happened? We loop through 0 to I minus 1, and then max use, if max use, dpt minus I, j minus I. Ah, here's the problem, you see. We got 0, but j minus 1, it's undefined. Well, for this case, I think we could insert a new false start, and this will solve the problem. No. dpi j, so, oh, no. This doesn't solve the problem because j will always start from 0, and we need to, if j is bigger than 0, then this. If not, it should be 0. A little tricky. Yeah, let's try. It seems like we are doing good. Let's try one more input like this. Two. Cool. I think so. It's actually working, but let's just try to submit. It will fail. Of course, the input. Always ask the input. What kind of input are we getting? For this one, we're not guaranteed that the array is not empty. So if prices length equals 0, return 0, return 0, return 0. Yeah, submit. Oh, we got a runtime error. It says terminate call after an instance of bad allocation. Well, so the input is huge, and we got a k like 1. It should be. This is a million, 1 billion, thousand, million, million. Yeah, million. What was 10 billion? I don't know. Anyway, so the k might be super huge. Well, if k is super huge, it is close to infinite, right? For prices like k, like this, if we want to do a transaction, we need a pair of start and end. So actually, the maximum will be half of the min. If k is over than that, it means infinite. So for infinite, we have dead 1, 2, 2. Best time to buy and sell stock. We have a different non-DP solution, which is like a one pass. Yeah, so I'll just copy the code here. Please, if you are interested, please search on my channel, and there's a detailed explanation on this problem. I copied it like here. Max profit for infinite. Okay, so let's add a extra. If prices, if k is bigger than prices, then divide by 2, we return prices like this. Okay, this should also work. Submit. Cool. You see, works accepted. We are accepted, and let's analyze the time and space. for time, loop k, all the numbers, and then all the numbers again, m, n, right, and space. Of course, we use mm, but actually, it is slow and a waste of space. You see, for the formula here, we only use the previous one and k minus 1. There's no k minus 2 thing, so we can just use one array, right, to reduce the space complexity. Let's try to do it without this matrix. We use only one array. It's like this, right? And now for each loop in here, we will create a new array. I will create a new one, which is the next array, new dp, yeah, and finally we return dp. So and the calculation is the same, but we will set not the dp, but set to new dp. When we get the previous one, new dpt is not. dpt is new dp, and dp t minus 1 is tp, right? So yeah, and after it, we set to dp to new dp. Let's try it. Cool. So we've successfully reduced the time space usage from mn to linear, which is n. Now for the time, actually it could do better, but I didn't come up with that. I didn't come up with this one actually. So I searched from materials, and actually I still didn't understand their code, because what I am going to improve is a little different from their approach. I just don't understand what their code is. But anyway, the time complexity doesn't change. So if you're interested, please continue. Continues. Let me introduce. Okay. So you see, for the loop here, we're using new dp. We loop through the letter, the numbers, and get the maximum, and then from 0, right? You see, if I equals 2, we're still using j from 0. It likes so we're creating, calculating over and over again. Let's look at more details about this equation. The new dpi actually is equals to the previous one, or the maximum if I use is the not previous one, but previous iteration result of previous one, plus this and this. This actually does not change, right? This does not change. If I took these prices out, it would mean, like you see, we update the max. The max actually is the smallest of these, right? This. So rather than we getting the max, we can rewrite it to let main price equals infinity. Now we are getting the mean price. The mean price would be math mean. This is could be rewritten like this, right? Yeah, so we could update the mean price to what? To this actually. So price is j subtracted with the dpj minus 1. This parenthesis is not needed. Now, so after this loop, we get the mean price, and what we do, we update to the prices I. Prices I subtract with mean price, right? Let's try run the code. Yeah, still working. Now you see for I from 1 to the price and j from 0 to I, we calculate the mean price. This mean price actually depends on what? Only j and the previous dp, j minus 1. Right? It's only depend this. So actually in this iteration, this mean price will not change. You know what I mean? So if I equals 2, this mean price at j, so this mean price only depending on the j, does not depending on the I. It's no relation with I. Yeah. So actually, these two could be merged together. Suppose like something like if you're looping through 2, 4, 1, and for each index you're looping from 0 to 4. Okay, so we can actually catch that, right? Just like what we did at the, just like what we did here, not this one, but one maximum one pass, 1 to 1, I think. Yeah, so actually the mean price could be moved out of this iteration. Do I make this clear? So the outer loop loops through 2, 4, 5, 1, and the inner loops through 2, 2, 4, 2, 4, 1. So it's actually the same. The mean price doesn't change. Okay, so now I'll move mean price out of the infinity. Now move out from this outer circle, outer loop, and then to what? So here's a little change. The j would be start from 1. It's okay, right? Okay. Wait a minute. Should I move the index? The mean price, we have to calculate the mean price. So I need to move to 0, and then we remove this. So mean price now becomes up to the mean price. So here should be what? Should be j, I. And if I is bigger than 0, then it should be this, right? Previous dp and 0. Yeah, this should be right. And now new dpi equals maximum max, new dpi previous one, max, right? If it's nothing, or the mean price is I, mean price. And yeah, and then we can update the dp to new one. So this should work. No, not a number. What's the problem? I see. So I says 0 here. Here's a problem. Okay, we add the ternary here. I don't know why these other people's solution doesn't have this ternary. Maybe they have different understanding. But I just think this might be easier for me to understand this problem, and it just doesn't matter that much. And yeah, because this code could adhere to our assumption here, right? Okay, now you see we're accepted and reduced to one for loop, so we have improved the time to OMM, right? Let's try submit. Cool, we're accepted. And there's one thing. Still, we can improve the space. You see, we are using linear space for dp here, and we actually create a new space here. So actually, it's 2. Doesn't matter though. But if you are going to improve a little more, we see that for the array, we're actually using the previous only this one, right? So rather than we are storing the previous dp, actually we can cache the previous updated item like this and improve the space. Though in the big O notation it doesn't change. Let's try to do that. So rather than creating a new dp, we will say what? I will say just update it in the dp. Okay, here is the new DP, but DP is a problem. So if we update it, this we update it, right? So before we update, okay, we set let prev. This one is okay. Let prev updated equals 0. We'll say equals 0. So here, because our array will be updated from left to right, right? So when we update it, we set it to before we update it, we cache the previous result, which is dpi. And so now here we could get this is the previous iteration, right? So we could use prev updated. I think this should work. Yeah. Cool. But I don't recommend. I have a hard time. I have to say it's hard to name this one. What is it? What's this? It is AK minus 1, J minus 1. So yeah. So I'd rather say we stop implementing this one, but keep the stick to the new array approach. Okay, so that's all for this problem. Hope it helps. Actually, it's very, I think for me, it's a very difficult one. Until now, I still don't understand how the other people is doing it without this ternary. Maybe we have a different formula. Anyway, our basic idea is the same. Hope it helps. See you next time. Bye bye.